Okay, good morning, good afternoon, good evening to all of you, and welcome to our Access to Space for All series of webinars on conducting R&D in hypergravity and microgravity. My name is Hazuki Mori of the United Nations Office for Outer Space Affairs, and it is my pleasure to welcome you to this webinar. So as you can see, we have been going through this 9-webinar series, and we have finally come to our 8th webinar, which is our UNOOSA Hypergravity Microgravity Opportunities and the DropTES 8th round Q&A session at the end. So before we begin, I'd like to give you some housekeeping rules. First, please turn off your cameras and your microphones through the webinar. Second, please use the chat box to ask any questions. We will have a dedicated Q&A session at the end, but you do not have to wait until then. Please put in any questions or comments you may have in the chat. Third, please answer our questionnaire form that we will put in the chat box later on. My colleague Wenbin will be active in the chat, sharing you useful links and also the questionnaire links. So please make sure to answer the questionnaire before you leave. We would really like to hear your feedback, especially regarding this whole webinar series as it is almost coming to an end. We really want to provide you with better webinars in the future as well. So please let us know what you thought of the whole series and especially on this webinar today. And last but not least, if you are on social media, please help us promote this webinar using the hashtag #AccessToSpace4All. We are active on Twitter, LinkedIn, Facebook, Instagram at UNOOSA. So this is what our 9 webinars have been looking like. The main objective of this webinar series is to really raise awareness of the many types of R&D done in hypergravity and microgravity and to really trigger the interest. Through these webinars, we want to provide theoretical and educational knowledge that can support hands-on opportunities, such as the Access to Space for All opportunities that we are going to present today, but also the many other activities done out in the world. The learning outcomes of these webinars are first, the fundamental special characteristics and advantages of hypergravity and microgravity environment, which we hope to cover in the first webinar in the introduction. Second, the overview of what type of research can be done in hypergravity and microgravity and its applications. So we've covered different scientific topics, starting with life science, physical science, and technology demonstration in the past 6 webinars. So an overview of basically what you can do in these different scientific fields. Third, the overview of the available modified gravity platforms, areas of application, and benefits. There were a lot of examples given in these scientific topics, scientific sessions as well, but today we'll be giving you more details about 5 different low gravity platforms that you can use. Fourth, how to develop an experiment to be conducted in hypergravity and microgravity. This has also been covered in the scientific sessions, but also today we will be covering it according to the different platforms that we have. And finally, the overview of the available experiment opportunities and existing networks and experts. I like to emphasize, I know most of you may know, but the links for all the webinars are all the same. So I believe you have registered and you're using the link that I've sent you. You can use this link to join our next webinar next week, which is the regional activities. All the updates of this webinar series will be posted to our Access to Space for All initiative website that you can see here. It is the first link up there. The webinar recordings and presentations will be posted to a different page, which is linked to the main page, called the past webinars of the Access to Space for All initiative. The presentations for today are actually already there. The recordings will be there as soon as I finish editing them. And the recordings can also be found on our YouTube channel, which is the UN Office for Outer Space Affairs. So I'd like to emphasize that today we will be focusing on the 5 different opportunities you can see in the hypergravity and microgravity track. This is all thanks to our amazing partners. Without our partners, this initiative would be nothing. So I'd really like to thank all our partners, and we are really happy to have them here to explain about the opportunities today. I'd also like to mention that DropTES is open until June 30th, so at the end of this month. As I've said earlier, after this whole session, we will be having a dedicated time to do some Q&A for the 8th round, which is currently open. So if you are interested in applying to DropTES, please stay with us for the entire webinar. And we will be giving more details and trying to answer more administrative and any technical questions you may have about DropTES. So please make sure to stay with us until the end. This morning we had the same session. Basically, we had mostly the same speakers. For the afternoon, for Bartolomeo, we will have a different speaker. So we'll have Christian talking on behalf of Airbus Defense and Space. So now I'd like to get into the contents of today's webinar. So we will be introducing our 5 opportunities, and our partners will be giving us more details about that. So I'd like to give the floor to our first speaker, starting with our ground opportunity. So we will be beginning with DropTES. I'd like to give the floor to Mr. Thorben Könemann of the Center of Applied Space Technology and Microgravity, ZARM. So Thorben, you have the floor.
Thank you very much, Hazuki, and good afternoon, good evening, and good morning to everyone. I start sharing my screen. So it should run, and now can go to the presentation. Yeah, as you heard, I would like to start with DropTES, so the Drop Tower Experience Series, which will take place at the Bremen Drop Tower. Yeah, as you heard, my name is Thorben Könemann, and I'm from the ZARM Drop Operation and Service Company. To the content of my talk, first of all, I will give you an insight of the Bremen Drop Tower, the Drop Tower facility itself. Then I go further into further details of DropTES, so the Drop Tower Experience Series. And later, at the end of my talk, I will give an outlook of our new facility, a next generation Drop Tower facility called Gravity Tower Bremen Pro. I would like to start with a video to give you an overall introduction about our Drop Tower facility, so that you get some moving pictures, so the insights of our facility.
Welcome to ZARM, the Center of Applied Space Technology and Microgravity at the University of Bremen. Here we are operating the Bremen Drop Tower, a large microgravity lab using the principle of free fall for experiments under conditions of near weightlessness. But how do we use free fall for microgravity research? What would happen if I had scales stuck to my feet and jumped from a diving platform into a swimming pool? It would show almost 0 kilograms because I'm in free fall. The only weight shown on the scales would be the result of the air drag. We could observe exactly the same reaction of the scales if we were jumping on a trampoline. In this case, the scales would show almost 0 weight all the way from going up to falling down again on the trampoline. And now we will see where the microgravity experiments take place. For a drop experiment, the capsule is pulled to the top of the drop tube to a height of 120 meters. From there it drops for almost 5 seconds before it lands in a container filled with tiny polystyrene balls, like these. The most extraordinary feature of the Bremen Drop Tower is the catapult system. It allows us to shoot the experiment from the bottom of the tower up to its top, from where it falls down again into the deceleration container. This way, instead of 110 meters for a simple drop, we can use a distance of 220 meters for free fall, providing a microgravity duration of almost 10 seconds, unmatched by any other drop facility worldwide. Another important feature is the fact that the free fall takes place in a vacuum. It takes these vacuum pumps 1.5 hours for pumping out 1,700 cubic meters of air out of the drop tube. Thanks to this procedure, we can eliminate the air resistance almost completely and achieve a very high quality of microgravity. The experiment takes place in only 1/1,000,000th of Earth gravity. Teams from all over the world and from all kinds of scientific fields come to Bremen to use the drop tower for their experiments. And the demand for experiment time is high. This is why we built another drop facility using a completely new technology which allows us to carry out hundreds of experiments every day. Stay tuned.
Okay, yeah. Thank you very much, Andreas, for the introduction to our facility. To give you again an overview about the ZARM Drop Tower facility. So It consists of an outer concrete shell, which is 146 meters high, and inside we have this vacuum steel tube. So we are able to provide you two operation modes: the drop mode, dropping the capsule from the top to into the deceleration container with 4.7 seconds in weightlessness, and then we have the option with the catapult system to shoot up the capsule to the top of the drop tower and then back. Falling back into the deceleration container with 9.3 seconds of weightlessness. That's worldwide unique. And another fact is that we are able to achieve a good vacuum of 10 Pascal inside our vacuum tube. And so we have a microgravity quality of 10 to minus 6 G. So a very good, excellent environment for experimenting in fundamental physics and other research fields. And this is also repeatable, so the experiments will take place under the same conditions every time. And this up to 3 times, because we have to evacuate this large drop tube of 1,700 cubic meters of air. Yeah, what we provide you also is an integration area and tools and hardware and so on. The campaign starts usually 1 or 2 weeks before the first launch or drop. Then you arrive with your hardware, and we will integrate your equipment into our capsule structure. You see it here. We provide you different platforms, and we mount then your hardware devices on those platforms. This is kind of our payload services. So each experiment is accompanied by one mechanical engineer and one electronical engineer. So you can rely on our expertise and so that we are able to bring your experiment into the right state for microgravity experimenting. You see here some overview about the different versions of capsules we provide you. So they differ in payload masses and also in size. We have the short drop capsule and the catapult capsule, which differs only in the outer structure. So from the payload dimension, they are the same. They differ only in the payload masses. And then the longer drop capsule with a higher payload area. Each capsule is equipped with our CCS, the capsule control system, so a computer system, a real-time computer system to give you to give commands to experiments, and between the ground control station and the capsule, we have a permanent communication and telecommand system. Each capsule is also equipped with a battery pack, so during the free fall, you need power to experiment. Yeah, an overview about the research areas and some facts and figures. So we started with the Bremen Drop Tower in 1990. Up to now, we have almost 9,300 drops or catapult launches performed. A lot of different types of experiments have been integrated, and usually you may have access to our facilities through our frame contracts with DLR and ESA. So it means that you write an application to those agencies, or you apply through DropTES. You see here the different types of research areas. You see nearly every research field is possible, mainly fundamental research, but also technology tests can be done. They are sorted here by the number of drops so far. So this is starting with combustion, then fundamental physics, fluid dynamics, astrophysics, material science needs a little bit more microgravity time, as well as biology. And then we have dedicated hardware tests to prepare space missions, chemistry as well, and of course students, experiments, programs taking place at the Bremen Drop Tower. So we have Drop Your Thesis, a similar program to DropTES. I'm talking about that in a few seconds. And we are also involved in AccSpace4All, so the European program launching some rockets and do balloon experiments from Kiruna, Sweden. Here for AccSpace4All, we are responsible for the German part. Yeah, as mentioned, DropTES. Yeah, DropTES is a UNOOSA Access to Space for All initiative. It's an annual science activity at the Bremen Drop Tower, which is located in Bremen, Germany. UNOOSA was first initiated in 2014, so this is the 8th round at the moment ongoing. and not ongoing 7th round is ongoing, the 8th round is will be long, as the call is open until this month. So involved is UNOOSA, DLR Space Agency, and the hosting institution, ZARM for sure. It's dedicated to student research teams, so from UN member states. It allows a real microgravity research project. It could be involved. Yeah, the students which are involved, who are involved, can be. Yeah, the topics can be accommodated in their bachelor, master, or PhD thesis. The project or the DropTES follows space project guidelines, and most important thing, each winning team will have the opportunity to do 5 drops or catapult launches at our facility. Travel, accommodation, and of course the drop tower utilization, including our technical support, are sponsored. You see here some figures, but we can, with our technical support, we can provide you computer systems, high-speed camera systems, and lasers. So this is not needed, especially for experiment. So you can have it as a provision on site. The programming language is English for sure. The schedule you see here at the bottom of the slide. At the moment we are here. So at the end of the announcement of opportunity, so you can submit your proposal by the end of this month. The selection will take place next month in July. Then you have time for your experiment preparation until May next year, and the campaign itself will take place at the end of June, beginning of July next year. And in the meanwhile, during the experiment preparation time, we will have a preliminary design review, so kind of a kickoff meeting, and you have to submit first a report, experiment report, then we will do a critical design review. Afterwards, or shortly before the campaigns of February, March, you should submit then the second report to get the final clearance from us to come to Bremen. And then, as I said, what else? Experiment takes place by the end of June, and a final report is required by the end of September. So the selection process is done by a selection board from UNOOSA, DLR, and ZARM. Every year we will select one team for DropTES. Your experiment preparation must be at your home laboratory, but you will all the time assisted by engineers from ZARM. We can also do some drawings for you and manufacture also some hardware parts, for instance, some mounts or chambers and so on. The experiment itself is distinguished in an experiment integration phase at the first week of your stay in Bremen, and the second week we will have then the drops or catapult launches. You see some impressions from the past rounds. I think you see happy faces. It's a nice opportunity, especially also it's a lot of fun. It's hard work, but it's also a lot of fun. You can visit also with us at the top of the drop tower, then we can have there a nice dinner or lunch. You see pictures from the control room, and you're also very famous. Probably sometimes it could be the case that the TV team is on site and film you for a German TV show or so on. And what I'd like to mention here is it's not necessary to have special capsule experiments. So there are also the chance to have special experiments utilizing our vacuum chamber or large vacuum chamber. You see it here. This was DropTES 2017. The team from Poland tested the deployment of their deorbiting sail. You see the sail here. So this is also feasible. So a lot of different ideas can be done at our drop tower, especially also not in the capsule. Then from the scientific point of view, so the time is a little bit too short, so to go into the detail of each experiment, but on our website, you can go to Drop Tower and Projects and to DropTES. Then you have here the different experiments and insights of their topics and what they performed in our tower. Also, there are related publications so that you get some ideas what is possible for DropTES. Then also on our project website, you have all other research which you see here: fluid dynamics, you can also look what is furthermore possible at our facility. Yeah, coming to the end of my presentation, for this I would like to introduce you to the Gravity Tower Bremen Pro, so the next generation drop tower system, which is currently under construction at our integration hall. This is a 60-meter high tower, which is connected to the concrete shell of our drop tower, and it's accommodated, as I said, in our integration hall. Here you see it here. This new facility can provide you over 12 experiments per hour. Due to the limited height of 60 meters, we are able to provide you only then 2.5 seconds in microgravity. But this is an active drop tower system, so a rear guided system. And for this, we use a rope drive to pull up this slider here or cabin up and downwards with the hydraulic winches to achieve an acceleration phase, then the microgravity phase when the capsule, this is a standard drop tower capsule, is detached here inside the slider, and the deceleration goes together at the end. So that you have a free-falling part, with this 2.5 seconds. Another mode is possible also with this facility then, where if you have a clamped mechanism between the cabin and the release and caging mechanism, we call this device here with the experiment capsule, then it's also possible to achieve Moon and Mars parabolas, so-called also partial G, so levels between 0.1 and 0.9 G. What I'd like to emphasize here is that the standard capsule can be used. So we have a lot of synergy effects with our drop tower. That means, for instance, you can test the parameter in the morning, 12 times the hour in the GTB Pro, then identifying the right parameter for a catapult experiment, for instance. Then you have 9.3 seconds in microgravity. So that there's a high flexibility between all modes. So drop mode, catapult mode, as well as Gravity Tower GTB Pro mode. Yeah, challenging was the accommodation of the hydraulic system or device. So you see here the vacuum chamber or the vacuum tube of the drop tower, and here's the concrete shell, so there's not enough space, but we could accommodate the hydraulic systems there. And the tower itself, it's, as I said, 60 meters high. It's connected to the tower, and the limiting height was the height of our integration hall. So, but nevertheless, this is our also a test facility, because with this technology we expect to go to a larger height. So then we need a dedicated tower for that purpose. What you see here inside is it's a slider, but this is a dummy slider. So with test masses, since mid of last year, we started with the test phase of the tower to move it upwards and downwards, and that it works. I can show you here in a short video. And you might expect, 2.5 seconds are not that long. They go up, and that was a phase then moving upwards a capsule. So then we achieved this 2.5 seconds. But for fundamental physics or combustion experiments, this time is fully sufficient to perform a lot of experiments, because those kind of experiments from those research fields need a lot of data points. Yeah, what are our next steps? At the moment, we finalize the software, so this is also very, very special, because scientists can operate this facility. So that is you will get a control desk to operate the Gravity Tower by your own. So it's more or less a lab device for you. And the slider and the subsystems are currently under manufacturing. You see here some parts, and this will be finalized in August this year. The complete tower will be tested in September. So, and we expect at the end of September and beginning of October that the tower is ready for the first utilization of external experiments. I would like to also emphasize that first of all, we simulated all activities of this active drop tower system, and the drive dynamics is much better than expected, so that we are very confident to provide you a very good system with less vibration and disturbances during the flight, as you might expect for an active system. Yeah, once also this capsule is a free-falling one, so then you have no influence by the rail-guided system. Once again, this facility is also available then for DropTES, so then you can think about for partial G experiments, for instance, and the high flexibility can be in this case so that you decide that you do some tests in the GTB Pro, for instance, and you can also then use drop or catapult launches from this 5 flights contingent you will get. So there's a lot of flexibility, and I must only say apply until the end of June, and we will looking forward to your proposals. That's my end of my talk, and once again, please follow us on Twitter, or if the video was not so good to see, and then you can also go to our ZARM YouTube channel. There are also some other videos about experiment ideas. And nevertheless, as I said, please visit our project site on the ZARM website. Thank you very much.
Thank you so much, Thorben, for the overview of DropTES and ZARM. I think it is a lot of detail that people will need to understand if you want to apply to the DropTES 8th round. So if you are interested, everyone, please make sure to check out the website that Thorben has mentioned on their ZARM website. And there are many other documents as well, so please make sure to check that all out. Thank you so much, Thorben.
Thank you, Hazuki.
Next, I'd like to introduce our second opportunity, which is HyperGES, which is one of our on-ground opportunities at ESA. I'd like to introduce Dr. Jack van Loon from the European Space Agency. So I will give the floor now to Jack.
Yeah, thank you, Hazuki. Good day to you all in this webinar. I'd like to explain something about the HyperGES program and the ESA Large Diameter Centrifuge. I'm from working for the European Space Agency and also affiliated to the Free University Amsterdam in the Netherlands. Something about ESA, the European Space Agency. It started off, it's in its official form in 1975, signing up with to ESA the 10 original member states you see here in Europe. And then quite some years later, 2020, we have 22 member states, and it's still increasing as we speak. ESA has various entities distributed all over Europe. Headquarters is in Paris. You have Earth observation activities near Rome. The Technology Center, which is the largest center of ESA, is in Noordwijk, the Netherlands. You have the Operations Center in Darmstadt, the Astronaut Center in Cologne, the Astronomy Center in Data Center also in Madrid, the Center for Commercialization and Partnership in Oxfordshire in the UK, in Belgium, there's part of the ground station network for ESA, and of course the launch facilities at French Guinea in Kourou. What I said, the largest entity is the Technology Center of the European Space Agency, which is in Noordwijk, the Netherlands. And it's really on the edge of the Netherlands, and the lab, we are doing the experiment here, actually the center of gravity, as I call it. You see it over here. ESTEC is located near the dunes, what you see vaguely here, and this even more vaguely part here is the North Sea, so we're very close to the beach. The TechMG List Lab within ESTEC is what you see here, of course, dominated by the round dome where we have the large diameter centrifuge. The gravitational research preparation lab where we have a smaller centrifuge for cell work. We also have microgravity simulators, the random positioning machine, the clinostats. Then we have the large life sciences lab where we have microscopes and flow benches, incubators and so on. Support lab, also incubators and freezers and autoclaves and so on. The wet lab where we have some other instruments, also done some experiments with respect to astrobiology, for instance. The clean room, where we are partly doing work for the planetary protection, so sending items to, for instance, Mars that need to be cleaned from biological items. That's what is done in the clean room. And we have a workbench and a meeting room that people can make use of during the campaign. The head of the lab is Robert Lindner. François Coubert is taking care of the contractual things for the LDC. Alan Dowser is my partner in crime, running the LDC facility over the last years. These are some images of the actual facility. So the main lab with incubators and flow benches and so on, meeting room, the wet lab with various general lab items, the support lab, the fume hood here, freezers, coolers, chemicals, autoclaves, water, small workshop. Of course, the control room for the LDC you see at the back here, and the preparation lab for the experiments for the LDC. The LDC here is it's an 8-meter diameter system, and the sort of experiments you can do is what I call the regular hypergravity experiment. So running an experiment at 2G, 5G, or 10G, we can go up to 20G. We can do launch simulations. We can look at, let's say, the hypergravity phase of parabolic flights, for instance. But you can also do some more, let's say, elaborate studies, or maybe sophisticated studies, whatever we call it, to look into, explore the gravity continuum. So to do all experiments here is the gravity scale going from microgravity all the way to AccSpace4All, whatever the X is for your system. And you can use the centrifuge to explore this hypergravity part and use this data to extrapolate to lower gravity values. So to model and to see what you might expect if you go to lower G levels, lower than 1G. That's one way of using centrifuges. You can also use centrifuges to simulate microgravity, although that sounds a bit strange. But you can do that based on what is called the reduced gravity paradigm. The upper part here is a regular spaceflight experiment where you are on Earth at 1G and you launch your system and then you are under microgravity, and then your system adapts to this microgravity environment. So you have this adaptation here. What you can do in the centrifuge is that you can adapt your system at the higher G levels, for instance 3 or 2G, and then you lower the G levels from 3 to 2 or from 2 to 1, and then again you have an adaptation of your system to this lower G. And this paradigm is especially applicable for life sciences experiments. But what is expected here, that you would have the same direction of changes in this reduced gravity paradigm as you would have under normal microgravity spaceflight conditions. So you can learn a lot on your system before going to actual spaceflight. So the main properties of the large diameter centrifuge: it's an 8-meter diameter when full swing out, 4 arms you see here. We have various locations for gondolas. We have 7 gondolas, although 6 on the arms and 1 central gondola for rotational controls. We have a swing out system, so the G factor is always perpendicular to the surface of your gondola. We can use 80 kilograms of payloads in each gondola. We can go up to 20 times Earth gravity, and it's a 22 kW motor to the system. Each gondola has a temperature sensor and a gravity sensor as well, but let's say for the experiments we have analog and video and digital video channels, serial communication channels, Ethernet channels, USB channels, power supply to the experiment. You can fix your experiment to various locations in the gondola, although most experiments don't need fixation. There are also gas and water supply lines if you need it to your experiment, for instance for cooling or for other reasons if you have to apply a gas to your system. And these are the outside connections to the gondola. I'm not going to explain the data and electronics interfaces of the LDC, but if you're interested, you can explore this graph later on in the webinar when you download it, or it's also in the manual of the LDC. You can find this as well, what the various connections are in the system. This is to emphasize again that it is a swing out system, which means that the gravity vector is always perpendicular to the floor of your gondola, so of your experiment as well. And so in terms of integration, most experiments just stand on the floor on an integration plate, base plate. and they're standing very well at 1G and even better at 2G or even better at 20G. So for most experiments, it's not really needed to fix them, but you can if you want. What you can do with this LDC, you can also program profiles, of course. This is a regular profile going from 1G to 20G. It takes about a minute to do that. It's it's a bit more than 2.5 tons of mass. We have to accelerate to about 100 kilometers an hour at 20G, and then you can, at the end, it takes also about a minute to stop from 20G to 1G again. This is a profile where we used a Soyuz launch. You see the various stages of that launch, and you can follow that with the LDC, so you can do a launch preparation experiment. Although it's an 8-meter diameter system, and although most of the actual size of the samples are relatively small, the G profile of your experiment is relatively homogeneous, but there is, of course, within the gondola, there is a gradient of your gravity profile. So the best place to put your sample is in the center of the gondola. So you have an even distribution of your gravity field within that sample and the most use of the large diameter of the centrifuge. Some experiment capacity possibilities. We have the possibilities to put gondolas at several locations on each arm, which means that you can have 2 gravity levels at the same run. Here, for instance, at 10G and this one at 5G. It's about a factor 2 or less you have for these locations. We can run, especially for life sciences, run incubators at different temperatures if needed. And then we can run these experiments for days or weeks or months, actually, if needed. For the HyperGES experiment, we have 2 weeks time, so in principle you could do a 2 weeks continuous experiment if needed. You can also, if your experiment setup is pretty large, you can make use of adjacent gondolas to put part of your, like an amplifier or some measurement instruments in an adjacent gondola and have connection between the two. So here's where the actual samples are, and here's where you have your support equipment to measure these samples or to guide them. You can do the preparation of your experiment in the lab and then take the full gondola and put them on the arm once you're ready. Here's some examples of some experiments. Impact, where we had a sort of regolith, where we studied the impact of the of particles on this regolith at high G. That was from the University of Glasgow in the UK. We looked at neurovestibular processes in a crab. You see here that, well, you don't see here, but here's a small black dot, which is an actual crab, where we measured the vestibular system. Together with Aberdeen, University of Thessaloniki, we looked into mass and heat transfer. There are quite some experiments done on mass and heat transfer under different gravity conditions, where some of these experiments are, let's say, the microgravity part is done in a parabolic flight or on the ISS, and the hypergravity part is done in the LDC. Planetary research, this is a model glacier, where you look into the behavior of glaciers at the expected behavior of glaciers at planets with a different gravity profile than on Earth. You can do model experiments on that. Bubble generation, a lot of bubble experiments. What you see here as well is an image of a fast camera looking into bubbles and Coriolis effects. Here we used 5 cameras for this experiment. These are zebrafish experiments done at hypergravity, but also at simulated microgravity in a random positioning machine. And these are the 2 microscopes that can be used for within the gondola, so at high G. One of them is a regular cell biological microscope, the EVOS M7000. The other one is a dedicated microscope for looking into 3D structures, well, larger 3D structures, I should say, with a light sheet microscope. As for the hypergravity proposal, a HyperGES proposal, what should be clearly addressed if you intend to send in a proposal to UNOOSA ESA for one of the coming campaigns. Make sure that it's very clear why you want to use the LDC. So for regular hypergravity studies or launch simulations, low gravity extrapolations, or this reduced gravity paradigm, the science and application background and rationale should be made very clear. So is there preliminary data either from your own or from literature You have to refer to peer-reviewed papers on that, preferably. How you want to use the LDC, identify the parameters you want to measure and how you want to measure them, either online or post-exposure, expected outcome and how to deal with that. Show the preliminary hardware configuration, so how do you plan to get your experiment accommodated within the gondola or in more gondolas. Think about the schedule and logistics, very important. There's not an unlimited amount of time. And also think about how to communicate your results, either in a report, peer-reviewed science papers, preferred conference presentations, and of course you have local and social media you can make use of. And before you upload, of course, recheck all the parts of the proposal. I mean, there are various parts you have to fill out, so be sure you do that. This is a page I'm not going to read, but here you see some of the examples of experiments done in the centrifuge, either on fluid physics, plasma physics, cell biology, technology, material sciences, geology, animal physiology, plant biology, or just some general topics. Here you see the peer-reviewed papers, the DOIs you can go to and look at them. So I think I gave a good overview. If you want to know more about hypergravity experiments, please also go to earlier presentations in this series of webinars. I think there's some very good presentations, very people that explained what you can do also with hypergravity in such facilities. But if you have other questions, you can either put it in the chat now or leave me an email or a text message on my mobile. Thank you very much.
Thank you so much, Jack, for this overview about HyperGES and about the Large Diameter Centrifuge facility. That was a lot of information, but please don't worry, we have all the documents on the website. And regarding HyperGES, we are in discussion with ESA to open the second round, hopefully during this year. So please stay tuned on our website. We will keep updating it with any new information we have. Thank you so much, Jack.
You're welcome.
Next, I'd like to move on to our on-orbit opportunities. So now I would like to introduce the Bartolomeo program. So the speaker would be from Airbus. Please let me introduce to you Christian Steimle from Bartolomeo. He is a Bartolomeo program manager at Airbus Defence and Space. My colleague Wenbin will be sharing the screen on behalf of him. Okay, I see it perfectly. So you have the floor, Christian. Oh, I don't see the presentation anymore, Wenbin, sorry. Can you try again?
Thank you very much, Hazuki, and good day to everybody, wherever you may be. Yeah, I would like to introduce you to our Bartolomeo on-orbit platform on the International Space Station, which is part of the Airbus's offer to the market with the Bartolomeo all-in-one space mission service. I am representing the service together with my colleague Yannick Jégo, who is always available. Also, if you approach us via the internet, those messages will always go to Yannick, and we will process as soon as possible your request. So, but now, enough of introductory words. Now I would like to jump into the middle of things, and Wenbin, if you go to the next slide, please. We have a here. So Airbus Defence and Space has developed this all-new on-orbit platform, Bartolomeo, here, together with the European Space Agency. So we are here in the public-private partnership with the agency that allowed us to install this space platform to the European Columbus module in the front porch of the International Space Station. Platform has been successfully installed and commissioned, and is now ready for service. So next slide, please. With Bartolomeo, every small to medium to large size payload can get access to space. So that this all new payload hosting opportunity on the ISS provides very good viewing conditions, because we are really at the front, as I said, front porch of the station. And the platform is designed to accommodate payloads in the range of 3 CubeSat units up to 1.2 cubic meter approximately, which corresponds then up to 450 kilograms in mass. So really, in comparison to a satellite mission solution, a really large payload. We usually rent out our slots that you see here in the image. We have up to 12 slots on the platform. So usually we rent out those slots for 1 year as a standard, and provide all the mission services that are required to bring the payload to that location in low Earth orbit, alongside the renting contract. This is a very cost-efficient solution. We start at 300 kilo euros per year with an all-in-one space mission service here. We also do have, as an evolutionary step, we have extraordinary data downlink capability. I will come to that later, but this is a cooperation with the German Aerospace Center that is providing high data downlink capability to all of our payloads. So Bartolomeo, the idea is behind is to provide all you need for the mission in one contract. As I said, this is a product that is offered in cooperation with the European Space Agency for European and worldwide payloads. For the US payloads, we do also have a further cooperation with NASA and the Center for the Advancement of Science in Space, or ISS National Lab, to use ISS resources for our payloads. So when you book a slot or a payload site on Bartolomeo, you get all the necessary mission elements that you see here. We launch the payload for you free of charge, because that's actually a service from the agencies. We do the payload transfer to the outside, from the inside to the outside, because all the payloads need to be launched pressurized. Inside visiting vehicles, supply vehicles that travel to the space station on a regular basis, on a 3 months on average basis. And then upon having been transferred to the outside, all our payloads are then installed fully robotically using the available ISS robotic system. And upon installation and successful commissioning of the payload, we grant the slot for 1 year of payload operations in the standard contract. Of course, extensions are always possible, so that the payload may stay as long as the space station is operated. We provide also data down on Earth through our cloud solution, the Airbus Cloud, which is operated by Airbus Defence and Space and offered also as part of the product. And as an optional service, we can bring back, and that's a unique feature, I must say, we can bring back payloads from the Bartolomeo platform, from external the International Space Station, bring them back to Earth, also using, if you will, the reversed operation scheme that I have described. So if you go to the next slide, thank you very much. Here's a view, an on-orbit view of our platform. We have successfully performed commissioning in February this year, after some very interesting installation steps we went through. First of all, the launch on SpaceX 20 last year, then a robotic installation on its position on Columbus, and finally an extravehicular astronaut activity that was required to mate our connectors, all the data and power connectors that supply at the end our payloads with the necessary resources from the Columbus module. So next slide, please, Wenbin. So the platform, as I said, grants or has 12 standardized, really look-alike payload sites that can all be used in the same fashion using the same standard interface provided to us by the US company Oceaneering Space Systems. That's the so-called GOLD 2 interface, the General Purpose Oceaneering Latching Device 2. That provides robotics, mating function, as well as the mechanical connection, as well as the electrical and the data connection, and can be mated fully robotically with an unlimited number of mating cycles. And this payload interface, together with the platform design, allows several different payload configurations. So you can fly the payload as what we call a slot configuration. This is then you fly it as a 1A, 1B, 2A, 2B, etc. payload, or you can link two payload sites to each other to allow for a larger size payload, or a payload that uses just two slots for whatever purpose. That makes the whole solution very versatile. This is for medium-sized and large-sized payloads. For small-sized payloads, we use the so-called AccSpace multi-payload carrier that you see here in the smaller image. This carrier uses a bit different interfaces, but it co-accommodates small-sized payloads in the CubeSat size range, co-accommodates them on one plate, hooks them up to a common avionics system that also provides 28 volts of power versus 120 volts commonly used on the space station. And this AccSpace, it's like the Greek ship traveling through waters. That's the name was selected on purpose because it brings together small-sized payloads, and through that co-accommodation we can reach a cost-efficient scenario here, where also the small payloads share ISS resources such as airlock cycles and robotics capabilities. And the unique feature of this carrier is that it can be outfitted and reconfigured on orbit by the ISS crew inside the space station. So also thereby we can enable very unique missions, and we can enable again the return of the payload after the mission, because once it comes back to the airlock, the ISS crew can take off payloads and send them back to Earth for post-mission inspection or whatever you would like to do. Next slide, please. So this is a close-up view of the AccSpace. It has very simple, very straightforward mechanical interfaces with simple captive bolts, where the payload can be easily bolted to the plate by the ISS crew. We provide, as I said, 28 volts to up to 8 payloads. There is also the 120 volts option on this adapter plate. And this is, of course, a solution that is specifically designed for small payloads that come out of our experience more from startup company and small businesses. And this is part of our joint approach with the European Space Agency to give more to give easy and fast turnaround access to space for exactly this kind of user group. Next slide, please. So here you see an overview of the viewing conditions on Bartolomeo, because a lot of use cases need a good view either to space or to Earth. And you see here a representative zenith and nadir view. What you see here is a so-called stereographic projection, or a fisheye view, if you will, of the nadir and zenith direction. And what you see is that, of course, being on the space station means that you see the space station in your view, and you also see other visiting vehicles, like you see here in the nadir especially. But you do see a lot of Earth in the nadir and a lot of unconstrained space in the zenith, which is good enough for most of the missions. And since this is a low cost or cost efficient mission solution, maybe this is those viewing conditions are just good enough for your mission. And those are excellent conditions that we provide on all of our payload sites. Next slide, please. So here's again an overview of the different payload site configurations you may select. The so-called single slot is our standard. We have up to 12 of those, which can be operated all in parallel and can be reconfigured upon each ISS flight. The volume, the standard volume, which budget, if you will, which we give to all our single slot payloads, is 700 times 800 times 1000 millimeters, so really large size, which allows for any kind of use case you may fit into this volume. This can have a mass up to 450 kilograms, and this comes at 3.5 million euros per year, end-to-end, launch included, no additional extra cost. Then we have the double slot solution. That is larger definitely. It's 800 by 1500 by 1000 millimeters per volume. Also has the 450 kilograms limitation, and it comes at 6.3 million euros per year. Again, end-to-end, launch included, operations included, no extra charge. Or you go for the shared slot solution on the Argus multi-payload carrier, which starts at 3U or 4 kilogram payload and starts at around 300 kilo euros per year, depending on the mission complexity. So this is our portfolio, covering everything from very small to very large. Next slide. Yeah, now we come to the partnerships. I already mentioned the partnership with the European Space Agency, which is the basic enabler for this offer to the market. And based on this ESA partnership, we have also agreed with the United Nations Office for Outer Space Affairs on flying a 3U payload free of charge on one of our Argus carrier missions. And in fact, we are here in the final stage of the selection process. So we are about soon to announce our first winner. This is going to happen presumably after the summer break. And we are, of course, excited very much excited to work with the UNOOSA on such interesting missions. We have received a lot of proposals for very, very good missions. And the one that we are going to announce is also equally interesting and will be very unique. Next slide. So I presented to you the Bartolomeo product, and we really are dedicated to make possible any kind of mission. We have here a selection of the most probable use cases you may think about. So starting with in-orbit testing, in-orbit demonstration. This is, of course, of high demand, because with Bartolomeo, we overcome the so-called valley of death for a low-level or low readiness level technology. You can fly with us independent from your TRL to make a fast-track development of your technology. Among those are also Pathfinder missions. So if you're unsure or if you have to calibrate a certain instrument, Bartolomeo is the platform to go. But also remote sensing cases, atmospheric research, very prominent, because we have a brilliant view also on on the Earth's atmosphere, and the limb view, so forward view, where you can see very well the boundary layer between space and the Earth's atmosphere for all kinds of measurements. And we also, and this is a very strong case, we also do have exposure missions, either material exposure or biologic sample exposure. Both are missions that are in preparation with our partner, the European Space Agency. We can think about even more. We can think about astrophysics using the zenith view, and even more exotic about on-orbit assembly cases where we can try out how to assemble or manufacture even in space for maybe future on-orbit societies, future more complex missions towards the moon, for example. Next slide, please. So that should be another video. Okay, so with that, I believe we are almost at the end of that presentation. So in summary, Bartolomeo is an all-in-one end-to-end mission service solution that is fully available to everybody of you. We're happy to make any commercial contract with you based on our standard offer or based on a specialized offer. Airbus is here only renting out the Bartolomeo platform. We have no restriction on flying anybody. We have no interest in your technology. We fully protect what you're about to do, and we do that fully supported by the European Space Agency and by the National Aeronautics and Space Agency in the US for customers worldwide. So Airbus, we make it fly.
Thank you so much, Christian, for the overview of the Bartolomeo platform and about our program. As Christian mentioned in the presentation, we are excited to announce the winner very soon. We will put everything on our website, and we will probably have an announcement of the winner event. So please join us when we have that as well. So thank you so much, Christian.
Very welcome. Thank you for your attention.
Thank you. Next, I'd like to move on to our next opportunity, which is the Chinese space station opportunity. Our speaker is Dr. Yang. He is the director of the International Cooperation Center of the Technology and Engineering Center for Space Utilization at the Chinese Academy of Sciences, and he will be presenting on behalf of China Manned Space Agency, who is our partner in this program.
Okay, thank you, Mori-san, and hello everyone. I'm Yang from China, and today I'm very glad and honored to be here, have the opportunity to share with you the general information of the China Space Station and also some very exciting updates of the construction progress of the China Space Station. Okay. Recently, we have two important launch about to construct the China Space Station. As you may notice that on April 29 this year, the core module was launched in Wenchang launching pad into low Earth orbit by Long March 5 rocket. And then after the just 1 month on May 29, the first cargo ship for China Space Station was launched also from Wenchang launching pad by Long March 5 rocket. This started the construction in space of the China Space Station. And just after 8 hours, the Tianzhou cargo ship docked to the main body of the Tianhe core module in autonomous rapid retinal and docking mode, and the assembling now fly in orbit. And, and within the next month, there will be several very important launches, and the China Space Station will be complete its construction phase within 2 years, which means that there's still 9 very important launch in the following month, and the China Space Station will be constructed by the end of 2022. And you will also notice, and in the coming days, in a couple of days, there will be another very important launch, which will bring the first crew to fly on board the China Space Station. When the construction completed, the China Space Station will be look like this in a T-shape assembly. It composed by 3 modules. I mean the crew module, the experiment module 1, and the experiment module 2. For the transportation system, the Tianzhou cargo ship can upload up to 6 tons of logistic staff and scientific hardware to orbit for each time. And also for the Shenzhou manned spaceship, it can upload 3 astronauts to fly on board and bring back 3 astronauts each time. Regarding to the utilization capability, and for the scientific hardware inside the pressure retinal cabin in CSS, there will be more than 20 scientific experiment racks. And for the outer side of the CSS, that's also for the external scientific hardware. That will be also payload adapter. There will be more than 7 payload adapter for external hardware. The altitude of CSS is around 350 kilometers to 450 kilometers, and the design lifetime is more than 10 years. The general microgravity level is 10 to minus 3 on average, well, with some additional technology, 10 to minus 7 can be achieved. The CSS can provide overall payload support for 17 of scientific hardware and 11 kilowatt of power supply can be supplied to the scientific research and scientific hardware dedicatedly. Usually, there will be 3 astronauts on board, and during the rotation phase, there will be 6 astronauts fly on board during that time. And yes, for the cargo ship, it can upload each time 16 of scientific hardware and also some logistic stuff for the astronauts to orbit. Yeah. There's some various research disciplines can be supported by the China Space Station, and for the, such as space medicine and also the space life science and biotechnology, space physics and space environment, and also astronomy in space, fluid physics and combustion, and also fundamental physics like earth science and materials science in space, and also no technology demonstration. To better support this kind of various research disciplines, there's a lot of scientific hardware is now under development or already developed for the China Space Station. This picture shows the layout of the scientific hardware inside the pressurized modules. And just in the core module, there's two experimental racks. I will provide some more detailed information on that. And there will be more experimental rack to fly on board the experimental module 1 and experimental module 2. Next. This slide shows the experimental rack that we have fly on board the core module. This we call it the containerized materials experimental rack. For this rack, it realizes a special experiment environment through electrostatic levitation technology. This rack can support research on metals and non-metals in a containerized condition in microgravity environment, so that it can explore the related solidification mechanism and also to promote the development of new materials in space. I'll go back now. And as you can see, the experiment rack is composed by several modules, several components. The main part is the containerized experiment platform, and which can hold the experiment samples. And also there's a containerized vacuum and pressurization unit and also there's a common support part like the experiment controller and the liquid cooling thermal control unit. And also there's some reserved space for future upgradation. As you can see, for each experiment rack, it can be treated as a very highly integrated laboratory that can provide the unique environment for research in certain disciplines, and also provide the human interface for the operation in orbit by the astronauts. Okay. Another experimental rack applied on core module is a medical samples analysis and high microgravity level rack. For this rack, can through the combined technology of magnetic levitation and also jet isolation. So the disturbance of CSS is isolated. That can forming a microgravity level, which can be 1 to 3 orders higher than the magnitude higher than the overall China space station environment. So it can provide a much quieter environment for space medicine analysis, and also some research need a very quiet environment, especially for some research like fundamental physics, etc. The hardware, regarding to the hardware, as you can see, there's a medical sample analysis system and also a medical sample controller. This also equipped a centrifuge. And the high microgravity level experiment system can, as I say, can provide a double isolation capability and provide a much quieter environment for research need high level microgravity. Okay, next one. Another kind of experimental rack, we can call it the modularized experimental rack. This rack is somehow like just a rack, but it can provide the interfaces to support small-size scientific payload. And that's a different standard interfaces. Like the scientific hardware can be developed in the shape of SPU or SDU, and the interfaces can be compatible with the ISS payload. And also, the rack can be made up to different combinations. So this kind of rack, means the modularized experimental rack, can provide flexibility for small-size hardware. This can also provide the potential opportunities for international cooperation projects as well as a commercial project. Okay. That's just some, as I said, it's some experiment scientific hardware to insert the pressurized module. Well, there's also a utilization capability be extended to the outside of the module, like we call it external scientific payload. The integrated exposed platforms are built on experiment module 1 and experiment module 2. This can provide very standard mechanical power and information, and also thermal control for exposed payloads. There are totally 3 large plus 16/7 standard holding points on this exposed platform. Moreover, there's also a robotic arm. Actually, there's a robotic arm are equipped and can install and uninstall as well as to operate the exposed payload, which provide much flexibility for the exposed scientific research, like space astronomy and Earth observation and some novel technology demonstration, but also some research on exposed biotechnology and material science, etc. Okay, next slide. There's now more than 1,000 scientific research are waiting for flight on board CSS, and among which there's a lot of international cooperative projects. And here in we have a very long heritage and fruitful cooperation with the UNOOSA. And now, within the first round, we have a 9 scientific projects have been selected and approved to be implemented on board CSS, and the more projects and the mission is plan is still undergoing, and in the future we will have more new round of corporate proposal with UNOOSA and have a more joint selected project with UNOOSA within this framework. And herein I listed the title of the cooperative project already selected, and it covers several research disciplines like earth science and also life science, biotechnology, and fluid physics and combustion, and space astronomy and technology demonstration. And that's also from a lot of countries and nations. And this project are now undergoing, and I'm also the teams are working together, and hopefully that the project will be fly on board CSS in 1 or 2 years, and when it's mature enough. And also I see some projects of this are now already with a very mature from the technology point of view, and we are working together to make the project, to integrate the project into the operation plan of the China Space Station. Okay. Next. Finally, I would like to give a little brief conclusion and a vision of the international cooperation, and we are always welcome the international partners to join the scientific utilization of the China Space Station, and in the way of cooperative research or joint payload development, and under the win-win principle, so that to benefit the scientific communities and to industries, and also to promote the peaceful use of outer space. Okay. Thank you for your attention. That's all.
Thank you so much, Dr. Yang, for this presentation. It's really nice to see the overview of the Chinese space station and also to learn about the updates of what's happening right now. And I saw on the chat, will there be a CSS project again? Definitely, we are working with CMSA to be able to provide the next opportunity. As you saw, we had the first round with 9 winners with a lot of international cooperation with different types of projects. We really hope to offer the second round. We're still in discussion, but please look at our website and we will keep you updated there. So thank you so much, Dr. Yang. Okay, now last but not least, I'd like to move on to our Dream Chaser opportunity. I'd like to invite to the floor Mr. Christopher Allison. He is joining us from the UK, actually, so not from the US, but the UK today. He is the Senior System Engineer of Mission Management at Sierra Space. So it used to be Sierra Nevada Corporation, but it is Sierra Space. I think Christopher will give you more explanation on that. So I'd like to give the floor to Christopher now. And we see the presentation in full screen perfectly.
Perfect. All right. And can you hear me okay?
Yep.
Great. Well, thank you, everybody, for joining today. So as mentioned, I want to go over Sierra Space, our Dream Chaser space plane, as well as our station or space station overview. As was mentioned, Sierra Space is probably a fairly new name to this community. Formerly, we were the Space Systems Division within Sierra Nevada Corporation, and as of June 1st, so just about a week ago, we were carved out from Sierra Nevada Corporation as our own company or independent commercial space company. So what is included in Sierra Space is all of our product lines, personnel, and contracts that were under our Sierra Nevada Corporation Space Systems Group, and those are being transferred into Sierra Space. So that's nearly 1,000 employees and multi-billion-dollar backlog of contracts. So that includes our resupply contract to the International Space Station, as well as a lot of our space technologies, our life habitat, and several other items that you can see here in the images on the right. In essence, we carved out this part of Sierra Nevada Corporation into Sierra Space to poise the company to build the future commercial space economy. And I'll go over a couple of the key product lines there that we're offering that will hopefully support a lot of different experimentation in that commercial LEO economy. So I mentioned kind of two core platforms. What we're probably most known for is our Dream Chaser platform. And the other platform that we have in development is our life habitat, large integrated flexible environment. So a combination of these two items is really setting kind of the foundation for our vision of the low Earth orbit economy and the space station that we want to develop in order to provide flexible and ample opportunity for different organizations to explore or fly experiments on orbit, develop products in space, etc. So our approach, obviously we have our initial flights on Dream Chaser as part of our cargo resupply contract to the International Space Station starting end of next year. Prior to the end of the International Space Station life on orbit, we want to begin flying what we're calling free flyer Dream Chaser missions. And we have, since 2016, been in collaboration with UNOOSA in order to put together kind of what we'll call a UN mission to fly payloads and experiments from non-spacefaring or nations that have limited access to space currently. So towards the end of ISS life, we want to start flying those individual free-flying Dream Chaser missions. And I'll go into a little bit more detail in a bit on the types of payloads that we can host on that type of platform. As early as 2028 is when we want to start the construction of our own commercial space station. Again, this is leveraging the technology of our life habitat. You can see here in this image, two life habitats connected together via nodes that also have berthing ports or docking ports on them for Dream Chaser or other visiting vehicles to come to the station. One thing I want to point out is, as we build up this station, we intend to build it to meet commercial demand. A single life habitat has nearly 300 cubic meters of usable volume with 3 floors in it. And so quite significant amount of space to either host astronauts, spaceflight participants, or experimentation. And then as early as 2030, again, following market demand, we have a vision of expanding this to what we call a 4 life system. So there's 4 life habitats bound together here by different nodes and serviced by other visiting vehicles such as Dream Chaser. So kind of focused on that kind of first increment, the Dream Chaser free flying mission. These would be missions where we would launch Dream Chaser into low Earth orbit, but not necessarily rendezvous with any other platform. This gives us a lot of flexibility in mission duration. We have more control over the micro-G environment, and we can customize the orbit. So depending on the complement of experiments that we have and the majority of the needs on the vehicle, we can really customize these missions to meet the application as best as possible. So types of payloads we could carry on those types of missions would be Earth return pressurized payloads. So these are conventionally on ISS right now, mid-deck lockers, though we can adapt to other form factors and be a bit customizable in that regard. That would sit inside the Dream Chaser here and then return for a soft landing on a runway. Other types of experiments that we could support is CubeSat or microsatellite deployments from the external slots on our cargo module on the rear of Dream Chaser. So once on orbit, we could deploy those satellites as part of the mission, kind of in a ride share capacity. We also have the ability to do disposal of pressurized or unpressurized payloads. So in these external slots where we can host small satellites, we can also host any experiments that would stay attached to the vehicle and collect data throughout the duration of the mission, and that data would be telemetered to the ground. Similarly, inside the cargo module, this pod on the back of Dream Chaser has a pressurized volume where we can host payloads. Those particular payloads would not be returned to Earth, but the data could be collected and sent back down to Earth, both internally and externally on these platforms notated here. So just in terms of a concept of operations or a ConOps for this free flyer, we would obviously launch on a launch vehicle. And one thing to note, we are pretty flexible on our launch vehicle that we can use. So once deployed on orbit, the vehicle would deploy critical systems and then begin the experimentation of whatever complement of payloads we have. Right now, we're targeting about 35 powered payloads. Again, that's sized off of like mid-deck lockers, which is the standard on ISS currently, and a science objective of about 3 weeks on orbit. Again, I pointed out previously on the chart that that's flexible depending on the types of payloads that we're flying on a particular mission and the needs of those payloads. After finishing the mission, we can land the Dream Chaser portion back on a runway and have immediate access to those payloads that maybe are time sensitive or time critical. So I mentioned the other kind of core component of our station vision here is the life habitat. And you can see here kind of an artist rendering of what that habitat looks like. Again, it's expandable on orbit, 27 feet, so 9-meter diameter, more or less. 300 cubic meter volume internally. So 3 floors can very comfortably house 2 to 4 astronauts, as well as 100 or so experiments within one of these life habitats. And then as you refer back to the kind of concept of building up our station with multiple of these connected by nodes, you can start to see that we have really a small city in space, if you will. So the types of things that we can do here on the life habitat, we can host certain payloads like is conducted on ISS currently. Again, flexible mission duration, we expect to have frequent opportunities to fly to and from the station. So that opens the possibility for rapid iteration on certain experiments where you get your hardware back on Earth, review something, make changes as needed, and then fly on a subsequent mission. So with the frequent access of vehicles to the station, we can also offer a flexible mission duration while hosted on the life habitat. And we expect to offer access to diverse resources and facilities. So we're looking at either whether that's crew time or potentially if there's a large need for like an advanced plant habitat to have one of those on the vehicle where principal investigators can utilize some of these laboratory type facilities on the platform. So at this point, we're still developing what a lot of this looks like, and we're eager to engage with different members of the community who would be developing payloads to understand their requirements, whether there's dedicated lab resources that we should outfit the vehicle with from the onset, or if there's certain things that we should just expect be included with certain payloads as they fly up to the station. So just to kind of summarize the different payload and research possibilities, we're really trying to not limit ourselves on what can be done on this platform, and we want to approach it from a very commercial sense. So we want to support human research and physiological research, biopharmaceutical, material sciences, fundamental sciences, technology demonstrations, manufacturing, whether that's for in-space use or on Earth use, satellite servicing and deployment from the station. We're open to things like a tourist destination where spaceflight participants can visit the station and then be either a test bed or even a starting point for certain exploration type missions. And in collaboration with our work with the UN, we're very aware of the 17 Sustainable Development Goals, and we do believe that through this platform and the life cycle of producing payloads to fly on our platform, that we can touch all 17 of these for a multitude of the different payloads that we can support moving forward. So at that point, I just wanted to provide kind of an update of where we are, what our vision is, the fact that we have now pivoted to a new company here, Sierra Space, and that we're excited for the different opportunities and the diverse offering that we can have on our different platforms moving forward for the scientific community. Thank you.
At Sierra Space, and as soon as we are ready to open an application, we will let you know on our website, so please stay tuned for that. And yeah, there's so much going on at Sierra Space with the new company and with the Dream Chaser and the space station. So in the future, maybe we can work more on the space station as well, but please stay tuned. We will definitely update everything on our website. So thank you so much. Okay. I'd like to move on to the Q&A. If you have any questions to any of the speakers, please make sure to write it down now because I'm going to start the Q&A. And just to emphasize, please answer our questionnaire form before you leave. We really would love to hear your feedback on our webinars. For this series, we only have one more webinar, but as a whole, we would really love to hear your opinions on our webinars. And especially for this webinar series, since we are kind of wrapping up, we would really like to hear your opinions so that we can provide you with better webinar series in the future. So please let us know. Okay, I'd like to move on to our Q&A. So the first question was from Matavan. This, I believe, is talking about DropTES. So I will send this question to Thorben. He is asking about, does the drop, so from the drop tower, does the drop involve some sort of sound creation like an echo chamber, as space is mostly vacuumed? Just looking at the number of tests already done, he is saying maybe this could be a good research, like the modular nature of electronics. So he is asking, yeah, if this drop involves some sound of creation, like an echo.
Yes, but once we evacuate our tower, so there must be no echo because the residual pressure is around 10 Pascal. So yeah, but it's strange to hear, but if we do, yeah, it's kind of echo, there will be a kind of echo, but we have no experience in that, yeah.
Okay.
Yeah, I hope that answers the question.
Thank you. I think that was clear. The second question is to Dr. Yang from Xing Li. About the astronauts. So if you could elaborate more on the astronauts, about 3 astronauts that will be sent to the Chinese space station. So I think it was 3 astronauts and maybe it was a couple of days. Maybe you can elaborate on the activities that the astronauts will be taking. Dr. Yang, if you're speaking, maybe you're muted. We can't hear you.
Okay. And sorry, I did not quite follow your question. Would you please just repeat again?
Yeah, of course. The question was about the astronauts that would be going to the Chinese space station. So are there 3 astronauts, and how long will they be going? what will they be doing? Do you have any more information about the astronauts and the activities at the Chinese space station?
Yes, and during the construction phase, and the duration of each crew is somehow flexible. And for when the CSS is fully constructed, and usually for each crew it will be stay on board for 6 months. 6 months, yes, when it is fully constructed.
Okay, thank you so much. 3 astronauts and 6 months. I see more questions coming in on the chat. So the next question is from SM to Christopher about Sierra Space, I'm guessing. Christopher, what might be a very ballpark figure to place an astronaut on your vehicle?
Thank you for the question. So at this point, we're still defining our business models, and what we've discovered as we started pricing out different elements here to fly either on Dream Chaser or to station is there's a lot of variability in terms of mission duration, timeline, requirements from, in the case of your question, astronaut, but even for a payload itself, what type of resources it needs access to. So, if there are folks on the call who are interested in, having more discussions about your specific requirements for our station, I would love if you guys reach out to me, and then we can engage on kind of one-on-one conversations about pricing. What I would say is that, there's a lot of commercial pricing being released now by, other vehicle operators, as well as the NASA commercial office for use on station. And, what we're developing our pricing structure around is to be competitive with those prices.
Okay, thank you for that clear answer. We have another question to you, which is from Manavan asking about the test. Did the test take place in the Nevada Air Force facility?
I assume the test being referred to here was an atmospheric flight test that we did a couple years ago. So that particular test occurred at an Air Force base in California, where there's a NASA research station.
Okay, thank you so much. The next question will be, in the future, will UNOOSA be providing opportunities for analog missions? So yes, we hope to. It is in our exploration track we have the visual of the tracks, and we do have this red little donut where we are marking the gaps that we do not have opportunities for. And yes, definitely analog missions in the exploration track is something we have identified as a gap. So in the future, we hope to be able to provide that, but currently we do not have anything at the moment. So if you know any organizations that could provide that, we would love to be in touch with them. But yeah, hopefully, definitely in the future for the exploration track. Okay, I think I'll go to our last question, which is also from Manaban, asking about the Chinese space station. Are there food production centers in the Chinese space station? What type of robots are being developed for better automation? So yeah, maybe Dr. Yang, you can answer if there are any food production centers. I'm not sure if there is, but anything related to food being developed, being researched.
Well, as far as I know, the most of the food for astronaut is prepared on the ground and then transported to CSS. And I'm not sure if my understanding of the food production center is correct, is the same with yours, but on board CSS, the food, they just kind of to heat the food and to re-prepare the food for the astronaut, but not fully product the food for astronaut on board. And for the robotics, and there's robotic arms equipped on CSS outside the modules, and there's several kind of robotic arms Some can help the EVA and I mean the extracurricular activity of astronauts, and also some with more sophisticated capability which can operate the scientific hardware. And for the robotic arms that also can work together or work in a combined mode, so this can provide more potential for the capability for the function of the robotic arm. Yes, thank you. That's all.
Thank you. Dr. Yang, we have one more comment from this person who asked the question. He is asking what he means by food production is like if you can grow plants for direct consumption. So if there's any, I guess it would be biology research, trying to grow plants on the space station and then using that for food for the astronauts. So yeah, he's asking if there's any centers like that or research like that.
Yes, for the food product, is most of that are for scientific research, and it's a very precious sample for this lab science research. Also, I don't think the Chinese astronauts are allowed to eat that.
Thank you so much for all our speakers and our partners for being part of this webinar. Some of the opportunities are open, like DropTES, but some of them are closed, and we are hoping to open more opportunities in the future, especially HyperGES. We hope to open one during this year. Bartolomeo, we will announce the winners soon, so please make sure to keep that in mind. For the Chinese space station, the first round 9 winners are actually developing their projects now, so we will keep updating information about them, and hopefully we will be able to open a second round with them soon. And for the Dream Chaser, we will keep you updated. We will keep discussing with Sierra Space to open more opportunities. So I guess I don't see anything going on. So from now, I'd like to close the general session, and for people who are interested in applying to the 8th round of DropTES, we will have a dedicated little session. I will be explaining about the announcement of opportunities, some questions and answers that we've done in the past. So if you're interested in DropTES, please stay with us. People that are not, I hope all of you stay, but people that are not, thank you so much for joining into our webinars. I'd like to emphasize that the next webinar will be same time, same place. So on Wednesdays from 4:30 Central Eastern Time. Our next webinar will be on the 16th about regional activities. So we have invited space agencies and other organizations that will be giving us some information about the different activities that are done regionally. So with this, we will be completing the 9 webinar series. You will have the whole introduction of hypergravity and microgravity in your head with the different examples of the scientific topics. You will understand the different platforms with today's session and also next week's session. And you will have a basic understanding of hypergravity and microgravity, which will lead you to do hands-on opportunities like the ones that were presented today. So as a whole, we really hope to see your applications and your engagement with us in our UNOOSA opportunities when we open them. So thank you so much for joining in. And I would like to start the DropTES Q&A session now. So okay, so I'd like to move on to the second part of this webinar, which is the DropTES 8th round Q&A session. It will be us, UNOOSA, and ZARM trying to answer questions about the 8th round. So there are many administrative and technical things that you may not fully understand. So we are here to answer your questions so that you'll have more material so that you can prepare for the deadline, which is at the end of this month, which is the 30th of June. So I'm going to really skip this part because Thorben actually explained everything for us beautifully in his presentation. But what is DropTES? Maybe it wasn't explained, but it started from 2014, and we have already done 7 rounds already, and currently we are opening for the 8th round. One major change, I guess, I'd like to emphasize is for the past rounds, we were only able to provide opportunities for 4 drops or catapult launches, but from this round, thanks to our partners ZARM and DLR, they have kindly said yes to 5 drops. So from this year, the team will be able to conduct 5 drops or catapult launches at the Bremen Drop Tower. So why DropTES? This has also been mentioned by Thorben, but I'd like to emphasize that with the developments, the duration has been extended to 9.3 seconds, which is really unmatched by any other drop facility worldwide. I think this was explained in the video as well. And testing in microgravity environment really represents an achievable entry point to learn and acquire new knowledge. And the Space Administration section of DLR will be bearing the cost to conduct these experiments. ZARM will be providing technical support during the campaign along with on-site apartment for student accommodation, and thus UNOOSA will be providing financial support for the travel of the selected team. So as you can see here, there is a lot of support coming from all directions. So I'd like to also emphasize that DropTES will contribute to the SDGs below because we foster innovation and supporting education on training on skill sets for developing cutting edge technology. So SDG 4, quality education, and SDG 9, industry, innovation, and infrastructure. As you can see here, we have, as I said, we have had 7 rounds. Actually, the last round, we're still in discussion on when to do the experiment because of the COVID situation. But however, you can see that we have winners from many different countries and regions with many different objectives. You can do technology demonstration. You can do medical experiments, biology experiments. So there are many things you can do in the Bremen Drop Tower as explained by Thorben earlier. So from here, I'm just going to quickly go through how you can apply to the 8th round. You can find all the documents on the website, which is here. There is a specific page for the 8th round. Maybe the easiest way is to type in DropTES 8th round UNOOSA or something like that. But if you go to our Access to Space4All Initiative website, go to the DropTES page, and then definitely you'll be able to go to the 8th round page. But please use this link, it will be faster. And I'd like to emphasize, please read and watch all the documents that are listed there. So the documents are the announcement of opportunity. This is very important. It has all the rules of this selection, so please make sure to read that. The second one is the application form, so please read this closely as well. And the next is FAQ, frequently asked questions. We've put it in a document, so we've done a few webinars and collected all the questions we received there and put them in a document, so please make sure to check that out as well. And all these reference materials are very important, and I think it will help you develop your experiment as well. So please make sure to read the ZARM Bremen Drop Tower website, the Zero-G Experiments on Earth. I think it's a video, and the past webinar materials, because we have materials from past winners as well. Yeah, and for the webinars, as I've said, we've conducted actually a few. So the first one there is how to build an application form. So this is really explaining in detail about the application form from A to Z. So please make sure to check that webinar out. I think it would be helpful because I'm really explaining what you can write, what you should write in each of the sections. The second is a series of webinars that we're doing now. If you want to gain more ideas on what you can do, go into the specific scientific topics as they provide you with ideas, and also the Drop Tower is explained as a great platform to do those experiments. So please check those out as well. The third webinar would be the tips for access to Space4All applications. So we have been doing various webinars that can help you with the communication awareness raising part, which we ask in the application form, the space law and regulations that you would need to know, and AI, like innovative technology that you can use as well. So we've been doing some webinars regarding that, so you can find that there. And the last one would be the experiences from the past winners of DropTES, which is a collection of presentations from the past winners. And I think that would be very helpful to get an idea, to learn about how they started and how they ended, which is very interesting. Okay, so from here, I'm going to quickly go through the announcement of our opportunity. Please make sure to read this document closely, as it is a very important document. So as you can see, I've just circled the really important parts. The deadline is at the end of this month, so June 30th. So the deadline time is Central Eastern Time. So please make sure to submit within Central Eastern Time. Sometimes we receive them too late, which is a bit problematic sometimes. So please make sure to send it before the deadline. And the expected profile of applicants is head of research institutions, public organizations or groups, and university professors. So as you can see there, and you will need to form a team with professors, postdoctoral researchers, and bachelor's, master's, and PhD students. So please make sure to read and make sure that your team is following these rules. And the number of selected applicants is as written as there. The thing is, you can have a larger team, but the funding that I've mentioned earlier, like the accommodation, the travel fees, will only be provided to this number written here. So please make sure to check that out. Here is the program schedule. It's relatively clear. So the deadline is June. We will be doing the selection in July. And after that, the timeline of the experiments is that we will start with the preparation. I think we'll be having a kickoff meeting with ZARM and the winners and also UNOOSA somewhere around August, September, and then we will start with the developments. The actual Drop Towers experiment series will be conducted next June within these weeks. This is still TBD, but hopefully it will be done in this week. And the submission of the final experiment report will be 3 months later after your experiment. So the eligibility criteria is as written here. Oops, sorry, my screen blacked out for a second. Please give me a second. Yeah, so it's open to research teams from research institutes, universities, and other public organizations that are located in member states of the United Nations. And as I've explained earlier, each team should consist up to 4 bachelor, master's, and or PhD students who must be endorsed by their academic supervisor. The eligibility criteria is very important, so please make sure to read the whole document. For the selection, it is relatively clear. I would say the selection board consists of us, UNOOSA, ZARM, and DLR, and we will be looking at all of these parts. I would like to emphasize that we really want to focus on inclusiveness. So we would like to see higher participation from women in all of our projects. Sorry, they will be ranked higher, and the link between the project and the Sustainable Development Goals. So we would all the other ones, actually, the scientific, the relevance, all of this is of course important, and it was in our past rounds, but I would say this inclusiveness and link between this SDGs are something relatively new that we've added, and we really want to see the focus here as well. Okay. The next is the financial support. This, as I mentioned earlier, so UNOOSA will be helping out with the travel costs, but as you can see here, we will not bear the expenses for the preparation, transport, and shipping of the experiment. So that will be on your side to make sure that you are able to ship or bring the experiment with you when you do your experiment at the Bremen Drop Tower. Besides that, I think this has been covered. Submission, as I've explained earlier, please send it within the deadline. We would like to see it in PDF. Please make sure to generate the Word document into PDF. For the signing page where we ask for the signs and for the signs of the organizations, we would like to have a scanned copy of the actual document. However, there was a question last time that it's hard to get the actual sign with everybody working from home and all that. So we are okay with electronic signing. However, at the end, after you actually get a signed version, we would like to see the scanned copy of that version as well. Okay, that was very quick, but that was what I wanted to go over for the announcement of opportunity. Just to go through some questions and some questions that we received, and this is all on the FAQ, but I'd like to mention is there a limit on team members? As I've explained earlier, each team should consist of up to 4 bachelor, master, and PhD students who must be endorsed by the academic supervisor, but the teams may be smaller or larger. The last time I believe Thorben was saying if it's smaller, it might be a bit difficult to go through all the tasks. If it's larger, the size should be around 10, as there is recommending the size to be 10 because there is space, what do you call it, like to fit in the facility. Yeah, Thorben could add that. Okay.
Yeah, integration hall. So the space we can offer for the integration of the experiment. So 10 is very, very maximum. Yeah.
Perfect. Thank you so much. So that is what we advise. What are the applications of microgravity? I think it is relatively clear, and also please make sure to check out the ZARM Drop Tower Bremen user manual, which is on our website. Thorben, I guess this is still the same version. I just want to confirm.
Yes, it's still the same version. So we are updating a new one, but we're waiting for the new facility. So this is still the valid version. Yeah.
Okay, thank you so much. Some other questions we had was how much the cost of an experiment is. So to build the actual experiment that you'll be testing, it will definitely depend on your ideas, what you plan to use and everything. So we do not have a ballpark figure, which we get questions a lot. So if you do want to know more, please try to see the past winners presentations. Maybe you can try to figure it out. And if you'd like to reach out to them, I think they had their websites and their emails on the presentation as well. So maybe you can reach out to them too. Yeah, these are all on the website, so I'm going to skip it. Is this opportunity covering the cost of taking the experiment to Germany? This is a no. So the fees for transportation will have to be borne by you. And because there's a lot of custom fees and all that, please, we can work with ZARM in advance for this. Thorben, if there's anything you can add to this part.
Yes, so if you need to transport your experiments, so we will assist you and look what is possible. Yeah, so I have nothing to add. Thanks.
Thank you. The last page is how should we decide on the 2 modes, drops or catapult launches? The answer is written there, but Thorben, if you'd like to add or give any advice on how you can decide on the type.
Yeah, first of all, it depends on the microgravity duration you need for your experiment. So please consider if you can conduct your experiment in 4.7 seconds, so then it's better to choose the drop mode, because for the catapult mode, you have also an initial acceleration. So we shoot up the capsule to the top of the drop tower. So then we have up to 30 G, which is not so critical. Because the piston of our catapult system follows a sine curve. So that means that we have a harmonic transition to the microgravity phase. So this is also a very sophisticated thing of our catapult system. But yeah, it depends at least then also of the payload mass and the payload dimensions you need. Yeah, so please consider the figures here of our standard capsules, so which fits. But the first driver is the phenomena, your experiment, your test, what time is required. Yeah.
From Matavan, how many hardware models got damaged on impact in percentage?
In percentage, I don't know, below 5 and 25 years or almost 30 years of operation. So the clue is that we drop the capsule in our deceleration container, and the deceleration force is up to 50 G. So that is not so much for hardware, and okay, for persons. So it's not allowed to drop persons, but it's so that if you would like to consider what kind of hardware is feasible to use in our facility, so then you can imagine once you can send your hardware via post delivery services, so then you can always drop in our capsule, because once you have a package and this package in a wagon and in an airplane or so else, you don't know how the people handle it, and this must withstand sometimes higher deceleration loads or G loads. So thus, I can say commercial hardware is feasible to drop. It depends a little bit on the mounting concept and on the design, but in this case, we will assist you. So to look what kind of hardware you would like to use, and we analyze it and give you a feedback what is possible or not.
Okay, thank you, Thorben. I think that was a very clear answer. Okay,
For test?
Any simulator for the test?
Simulator for the test? What kind of test? So it's not needed to do a space-proof or to do shaker test, vibration test, or a G-load test in advance. So it's based on experiences. So as I said, our deceleration force is below 50 G, so in usual 40 G. So that's not so critical for hardware. Yeah. So I don't know so much designs were damaged, so that it was damaged due to to fix it not in the right way, to forgot a screw or something like that. So human errors, more or less.
Okay, thank you. I see in the chat that Madhavan has answered thanks and beautiful, so I think he is satisfied with the answer. I don't see any more questions. If you have anything, please reach out to us at UNOOSA. We will be happy to answer any questions that are coming in for the 8th round. You have 1 month, which is actually perfectly enough to build an application form. So we really look forward to receiving your application. So please make sure to send it within the deadline. If there's nothing to add, Thorben, do you have anything?
No. Yeah, I'm looking forward to receiving a lot of proposals from you. That's all. And if you have questions, please, write an email to UNOOSA and then or to me. So thanks for staying with us. And
Yep, thank you so much. As Thorben said, we are really looking forward to more applications. And thank you so much for staying with us. And we really look forward to getting your applications. So thank you so much, everyone. Take care. Have a nice day, evening, morning, wherever you are.
yeah.
Thank you.
Okay.